Every ton of raw meal that goes into your kiln, every ton of clinker that comes out, every truck that leaves your gate, somewhere, a weighing system decided how much. Get that number wrong by even 0.5%, and it compounds across a 5,000 ton per day plant into real money, real quality problems, and real disputes with your customers. This is video 1 of a new series on industrial weighing, weigh feeders, weigh bridges, load cells, and everything that turns a mechanical force into a number you can trust. I'm going to build this the same way I built the ladder logic series, from the ground up, with the theory, then the real hardware, then the faults you'll actually chase on shift. In a cement plant, and this applies just as much to steel, fertilizer, food processing, any bulk material plant, weighing isn't a side instrument. It's a control input. Your raw mill feed proportioning depends on weigh feeders reading correctly, ton for ton, so your raw mix chemistry stays inside spec. Your coal feed to the kiln depends on a weigh feeder holding a stable set point, because a swing in fuel rate shows up as a swing in burning zone temperature within minutes. Your dispatch weighbridge decides what gets billed to the customer, and that number is legally and commercially binding. So when we say, weighing instrumentation, we're not talking about a scale in a warehouse. We're talking about a real-time process measurement that feeds directly into control loops and into your P&L. Every weighing system, no matter how complex the mechanical arrangement, does the same basic job: convert a mechanical force, weight, pressing down under gravity, into an electrical signal you can read, log, and control on. The heart of nearly every modern weighing system is the load cell. Inside that load cell is a strain gauge, a thin conductive element bonded to a metal body. When weight is applied, the body deflects. We're talking microstrain, deflection you'd never see with your eye, and that deflection stretches or compresses the strain gauge, which changes its electrical resistance. We arrange 4 of these strain gauges into a Wheatstone bridge circuit. 2 arms go into tension, 2 go into compression, and the bridge produces a small millivolt output proportional to the load, typically in the range of 2 millivolts per volt of excitation at rated capacity. That signal is tiny, it's noisy, and it needs to travel from a load cell mounted in a dusty, vibrating plant environment back to a junction box and then to an indicator or a PLC analog input without picking up interference. That journey, and everything that can go wrong along it, is what this series is really about. Let me walk you through where this shows up on your plant, because we'll cover each of these in depth as separate videos. Belt weigh feeders, these sit under raw material bins and coal bins, weighing material on a moving belt in real time and controlling belt speed to hold a mass flow set point. This is a closed control loop, and it's probably the weighing system you touch most often. Loss in weight feeders, common on additive and minor ingredient dosing, where the hole hopper sits on load cells and the controller doses by watching the weight drop over time, not by watching a belt. Weigh bridges, the truck scales at your gate. Multiple load cells under a single deck, summed together, used for commercial custody transfer. These carry legal metrology requirements because money changes hands based on that number. Hopper and silo weighing, storage vessels sitting on 3 or 4 load cells, used for inventory tracking and sometimes for batch dosing. Rotary and screw feeders, where you're inferring mass flow from volumetric displacement and material density, which brings its own calibration headaches. And behind every one of these, the same signal chain: load cell, junction box, cable run, indicator or transmitter, and finally your PLC or DCS. Over the next 11 videos, we're going deep on each piece of that chain. You'll get the working principle of load cells and strain gauges, the full mechanics of belt weigh feeder operation and calibration, static and dynamic, loss in weight systems, weighbridge construction and legal calibration procedure, hopper and silo multi-load cell arrangements, rotary and screw feeder weighing, and a dedicated fault tracing video covering drift, creep, moisture ingress, and junction box problems, because that's where most of your callouts will actually come from. We'll close the series with a preventive maintenance video, the calibration schedule, the inspection checklist, and the spares you should actually be holding, so your team isn't chasing weighing complaints reactively. If you've worked on a plant floor, you already know a weighing system doesn't fail loudly. It doesn't trip a breaker or drop an alarm. It just quietly starts feeding you a wrong number, and by the time production notices the raw mix is off, or the customer disputes a weighbridge ticket, the root cause could be a corroded load cell 3 weeks old. That's exactly why this series exists, so your team can catch it before it costs you. Subscribe if you haven't, and I'll see you in video 2, where we go inside the load cell itself, strain gauge theory, Wheatstone bridge math, and the different load cell types you'll find on your plant.